Can you hear me? පාඩමාව ඇහෙනවද?
Yes, sir. Good afternoon.
Okay. Okay, we will start now. I am Timira Madhusankar, mechanical engineer, and now I am working in Sabaragama University as a as a assistant lecturer, and also nowadays I am doing my higher study in University of Moratuwa regarding industrial automation. Okay, so in this lecture series we will discuss about fluid mechanics. Okay, so what is the fluid mechanics? In this lecture series, you can identify how is behavior in a fluid, and also what are the properties in these fluids, and what are the main applications, and real world applications. Likewise, thing you can identify through this lecture series. Okay, so first of all, I will give reference book details. So you can use uh, these reference books. Okay, you can study using these reference books, and also these are the outcome in outlines in our lecture series. Okay, firstly I will introduce what are the things in this lecture, and after that we will discuss fluid flow types, and what are the one-dimensional, two-dimensional, and three-dimensional fluid flow, and we can identify open system and closed system, and what is the meaning of discharge, how can we calculate discharge, and finally we will discuss what are the applications, and also we can do some calculation parts. So continuity of flow and momentum of flow we will discuss in future. So these are the learning outcomes. Okay, after completing this lecture series, you will be able to know about applicable to fluid in motions, and describe the constructional details and operational principle of hydraulic pumps, their performance, characteristic, and applications. And also you can identify some maintenance procedure in hydraulic system, how to hydraulic system are working, and also you can identify what are the specification in hydraulic systems. And finally, you can identify hydraulic turbines, their working principles, their characteristics, and what are the real world applications in hydraulic turbines. Likewise, thing you can identify after completing this module. Okay, so this is the first thing we need to know about fluid mechanics. Okay, fluid mechanics is study of the fluid behavior. So we can categorize main two categories. Okay, there are fluid statistics and fluid dynamics. In this lecture series, we will discuss about fluid dynamics part. Okay, so fluid statistic mean we can study the behavior of fluid at rest. It's mean there are no any motion inside of the fluid. So in fluid dynamics mean we can study behavior of fluid at motion. Okay. We will discuss about motion of the fluid. In fluid static mean study the behavior of the fluid at rest. In this case, we will discuss what are the properties and what are the density behavior and viscosities. Likewise, thing we will discuss in this part. And fluid dynamics is very important thing for engineering field and also physics. So this is the definition for a fluid. Okay, a fluid is defined as a substance that continually deform under an applied shear stress regardless of the magnitude of the applied stresses, whereas the solid can resist an applied force by static deformation. Okay, so in this case, we can identify a fluid is a liquid or gas that may continuously move and deformation under an applied shear stress or external force according to the fluid definition. Okay, so I will move to next slide. This is the fluid applications. You can identify what are the fluid applications in this slide. Aerodynamics. I think you have heard about the aerodynamics. It's very useful applications in fluid dynamics. Aerodynamics mean we will discuss with the air, no? Yeah. So we can study how behave air with dynamics. Okay. So this aerodynamics used for some aeroplane design and also car design, high-speed car designs, a lot of things. Okay, so you can study about the aerodynamics on this lecture series. Okay, so aerodynamics is a study of how gases interact with moving bodies. Okay, then gases mean air. What are the gases we can consider as a fluid? So because the gas that we encounter most is air, aerodynamics is primarily concerned with the forces of drag and lift, which are caused by air passing over and around solid bodies. Okay. This is the hydrodynamics. Hydrodynamics mean it's like aerodynamics, but little bit change because we work with the fluid. Okay, fluid mean it's like a liquid. So in hydrodynamics, used for design ships, pipelines, pump, dam, hydraulic turbines, and some river drifts and groundwater and underground oil deposits, like I think we can use. Okay. So there are 4 types of fluids flows we can identify. First one is uniform flow. Second one is non-uniform flow. Third one is steady flow, unsteady flow. There are 4 types. Okay. Uniform flow mean main flow parameters do not change with distance along the flow. Okay. the velocity at a given instant is the same in magnitude and direction at every point in the fluid. Its main flow parameters mean velocity and flow rate. Likewise, thing do not change with time. Okay. Sorry, do not change with distance. Okay, do not change with distance. It's I will draw a pipe. Okay, I will draw a pipe. Then I will consider a fluid particle, and this will move to this point to that point. Okay, this point. Then in this point, flow rate, I will take Q1. Velocity, I will take V1. Cross-sectional area, I will take A1. Okay. In this area, flow rate, I will take Q2. Velocity, I will take V2. Cross-sectional area, I will take A2. According to uniform flow, okay, we can say Q1 equal Q2. Okay, V1 equal V2. A1 equal A2. Okay. Main flow parameters do not change with distance along the flow. Okay. Flow distance means this location to this location. Okay. Flow is going this direction. Okay. The velocity at a given instant in the same magnitude than direction at every point in the fluid. Okay. Same magnitude and direction. Same in magnitude and direction at every point in the fluid. Okay. So non-uniform flow means the velocity changes from point to point. The flow is described as non-uniform. It means I will draw a pipeline and I will consider fluid is going through this pipe. Then I will take one point, one particle in this one molecule, and it will move this location to that location. Okay. Then this location flow rate, I will take Q1 discharge, I will take Q2, Q2, Q1, velocity V1, velocity 0.2 in V2, in first point area, cross-sectional area, pipe cross-sectional area, I will take A1. A1, this area A2. In a non-uniform flow, Q1 equal Q2. Flow rate is equal. Okay. Q1 equal Q2. But velocity is not equal. Velocity V1 not equal to V2. And also cross-sectional area is not equal to A1 is not equal to A2. Okay, the window. Sorry for issue. Okay, I will discuss about the non-uniform flow, no? Okay. Then in this non-uniform flow, velocity change from point to point. It's mean velocity not equal to uh, uh, velocity 1 not equal to velocity 2. It's mean in first point velocity not equal to second point velocity. Okay. So steady flow mean main flow parameters don't change with time. Okay. Main flow parameters, velocity, pressure, cross-sectional area of the stream may vary from point to point, but do not change with time. Okay. These parameters don't change with, do not change with time. Okay. Then we can call steady flow. Okay. I will show a diagram for it. This one is steady flow. There are no any changes, velocity or velocity, pressure, or cross section. So unsteady flow mean main flow parameters can be changed with time. Okay, if at a given point condition do change with time, the flow is described as unsteady. Okay, so this is an example for it. Okay, you can see this streamline. Okay, then it has been changed. Okay, size is changed. Then velocity is changed time to time. Okay, so you need to identify these things: uniform flow, non-uniform flow, steady flow, unsteady flow. These are very important thing in fluid mechanics. Okay. So we will move to next one. What is the incompressible flow? Incompressible flow mean what is the incompressible flow? What is the compressible flow? Compressible flow mean, okay, I will draw a piston like this, okay. Then I will put a fluid to inside of the piston. I will put the fluid. Then I will apply a force. Then in this piston, volume and density can be changed. Okay. The volume and density will be changed. Okay. So this type of fluid we can take compressible fluid. Okay. Then non-incompressible fluid means in this type of incompressible mean when we apply force, when we apply force, volume and density not be changed. Okay. Then according to force, volume does not change. Volume no need to change. Density no need to change. Okay. Then compressible flow mean volume can be changed and also density can be changed. Okay. Then non-viscous flow mean non-viscous flow is characterized by random, erratic, unpredictable motion of fluid. Okay, no internal friction between adjusted layers. You have know about the fluid. Fluid consists of different layers. Okay, inside of the fluid, we can consider different layers. I will show you some example for fluid layers in future. So you can see inside of the fluid, we can see some different layers. Okay, non-viscous flow. We will discuss now. Then viscous flow means there is an internal friction between adjacent layers. It means fluid layer, between fluid layer, we can see some friction. Okay, we can see some friction between each fluid layers. Okay, so in viscous flow, fluid moves in adjacent layers without slip. Okay, viscous flow occurs at low velocity. Okay, viscous flow occurs at low velocity. You can see a volume profile. Okay, this is a pipeline. This one is pipeline surface. Okay, this is fluid. Then this one is indicated velocity profile. In this area, velocities become maximum, Vmax. Okay, in this area, velocities become 0. Okay, this area very low velocity, it's become 0 because due to their friction. Okay, and also these are the streamlines. Okay, streamlines. So between different fluid layers, we can identify some friction. Okay. Okay. This they have given an average velocity using this line. Okay. We can get this one. Maximum velocity given in this area. Okay. So viscous flow in a pipeline, there is a friction between pipe wall and fluid. Then the fluid which is close to wall is zero. Okay, it's mean this one. This area of velocity is very low and it is very close to zero. Okay, fluid. There is a friction between pipe wall and fluid. Friction between pipe wall and fluid. It's mean this area. Then fluid which is close to wall is zero. Okay. Then velocity is equal to zero in this area. Okay. Due to friction. Okay. So you can see this is a 3D design. It's a parabolic area. You can see this is the parabolic type. Maximum velocity due in this area. In laminar flow through a pipe, water travel in cylindrical layers moving faster in the center. Okay, it's mean in this area velocity is very high. It's the inner surface of pipe. Okay, then this area velocity is very low. It's very close to V equals zero. Okay, this is a 2D drawing. You can identify these are the fluid layers. Okay, it's V equals zero layer. You can see this area. This is the velocity profile. We can draw like this. Okay. This 3D model converted into 2D model. Okay, you can identify using this image. It's very clear image. Vmax given by this layer in this layer. Okay, it's main middle one. Okay. 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 In this slide, we will discuss what are the real difference between real fluid and ideal fluids. Okay. We will discuss. What is the real fluid? Real fluid mean in the world we can identify real fluid, but we cannot take any ideal fluids. Okay, real fluid mean we can get naturally. We can get it is existing thing. Okay, ideal fluid mean we can't find it because no friction and its viscosity is very low. It's mean zero, very close to zero. Ideal fluid, and it should be incompressible, and also there are no any friction between layers. Okay, in ideal fluid. It is only we can find in theoretical way. Okay, ideal fluid we can find only in theoretical. We can use our calculations and everything, but we can really take ideal fluids. We can't to take in real world. Okay, so some differences you can identify using this chart. Okay, real fluid exists in nature, but ideal fluid exists only in theory. It's mean we use this one for our calculation purpose. Okay, then real fluid, in real fluid, non-zero viscosity. Okay, but in ideal fluid we will consider viscosity is zero. Then real fluid can be compressed. Okay, can be compressed. We can apply a force and we can compress. Then ideal fluid we cannot compress. Okay, it's mean density, rho, density and volume we can't change in ideal fluid. Okay, it's mean incompressible fluid. No? Then finite bulk modules. Okay, then ideal fluid is infinite bulk modules. Okay. Then real fluid is no slip boundary condition is applicable. You see parabolic shapes. Can see. I will show you this area is parabolic. No, so no slip boundaries condition is not applicable in an ideal fluid. Okay, flat face shape flowing pipes. Okay, it's mean this one. Okay, you can see this. These are the streamlines. Okay, these are very same way moving through a pipe. Okay, same way. There are no any changes between streamlines. Okay, so we can identify shear stresses are developed between fluid layers in a real fluid, but there are no shear stresses are available between ideal fluid layers. Okay, so these are the thing in real fluid versus ideal fluids. So this area you can identify real fluid streamlines, how is occur. You can identify, you can get idea about the behavior in streamlines. Okay, so I will put some notes about compressible fluid and incompressible fluids to this slide. All the fluids are compressible in nature, but the mathematical analysis, some of the fluid can be assumed as incompressible. Okay, we use only our calculation purpose. Okay, and incompressible fluid under steady flow condition and provided the changes of density are small, it is often possible to simplify the analysis of a problem by assuming that the fluid is incompressible and the constant density. Okay. So compressible fluids are the fluid that can change its density by compression. Most the gases and gases are compressible. Okay. Okay. Most of the gases are compressible. Okay. Incompressible mean it should be a ideal gas or ideal liquid. Okay. So these are the thing we have discussed using this sketch. This is the piston. Okay. Piston and how to vary this density and volume after applying this force. Okay, we have discussed. In this slide, we will discuss 1, 2, and 3-dimensional flow. What is the meaning of 1, 2, 3-dimensional? One-dimensional mean, okay, we can discuss parameters in a one way. It's mean I will draw a 3D axis x, y, and z. So one-dimensional flow means if the factors or parameters such as velocity, pressure, and elevation describe the flow at a given instance vary only along the direction of flow and not across the cross-section at any point. It's mean we can consider fluid going through y-axis, fluid going through a pipe, then direction is y. Okay. Then properties, its properties mean velocity, pressure, direction should be this direction, y direction. It's not to the, should not to the x direction. Okay. So only should be y direction. Okay. Only should be one direction. It's mean it should be along with fluid going direction. Okay. Then two-dimensional mean it is assumed that the flow parameters may vary in the direction of flow and in one direction at right angles, so that the streamlines are covered laying in a plane and are identical in all planes parallel to this plane. It's mean we can consider it can be more in another direction. Okay. It's mean we can consider velocity and pressure can be changed on another directions. Okay, it's mean two directions, x and y direction. Okay, x and y direction can be changed. Its pressure and velocity. Okay, so three-dimensional mean you can see a figure. Okay, using this figure, you can identify this is a pipeline. Then liquid is going through this direction, going through pipe, going this direction, and its velocity profile also this direction. Okay, x direction. It's mean one-dimensional flow. Two-dimensional mean it can be changed. This is the streamline. Okay, then fluid is going through a pipe. Then we can see a disturb item in the middle of the pipe. Then in this area, you can see its velocity direction change. Okay, this direction and this direction. Okay, velocity can be changed according to this item particle. Okay, then and for flow rate also change due to flow rate, no, cross-sectional area also changed due to this situation. Okay, you can see cross-sectional area also changing this area. Okay, it should be a flow rate same in both areas. So 3D mean when the fluid flow at x, y, z directions, it means x, X, Y, Z. So Y, X, Z. Okay, X, Y, Z directions. It is called a three-dimensional flow. It's mean pressure velocity can be changed according to these directions. X, O, Y, Z. Any direction can be changed. Okay. Velocity profile of a fluid flowing through a pipe is as follows, and the velocity is minimum at boundary wall and maximum at the center. It's mean we will discuss in last slide. This is the velocity profile. Okay, in a fluid. Then you can identify maximum velocity in this area, minimum velocity that area. So 3D drawing is given. This area you can identify how to when the occur this situation. Okay. So fluid flow in a pipe is three-dimensional, but since it is axisymmetric, axisymmetric mean it's symmetric to different axes. Okay. Then it can be reduced two-dimensional flow by using a system of cylindrical coordinations. X in the direction of flow and R the radius define the position in the cross-section area. Okay, R define radius of cross-sectional area. You can see this area. It's a 3D, three-dimensional flow. Okay. So streamline is a very important thing to our we can discuss velocity profile using streamlines. Okay, you can see this is the minimum little bit small one. This one is and different sizes you can identify. This one is the maximum one. It's mean velocity is very high. Using this streamline, you can identify velocity profile. Okay. Path of particles. A streamline is a line that is tangential to the instantaneous velocity direction. Okay. If we receive the curve shape streamline, you can get velocity using tangent lines. Okay. In this point, we can draw a tangent. P point, we can draw a tangent and velocity is VP. In this point, Q point, we can draw a tangent and we can get velocity. And R point also same. Okay. So no crossing of streamlines. Streamlines, there are no crossings. Okay. So, okay. In this slide, we will discuss about laminar versus turbulent flow. What is the laminar flow? Okay. What is the laminar flow? Laminar flow means when I consider pipeline, I will consider fluid is going through this line. Okay. So I will consider some particles in this flow. Then these particles should be more straightly. This way. this particle should be more very straight way. Okay. These are we call laminar flow. Okay. Laminar flow occur fluid at a low speed. It's mean low speed mean fluid should be very low velocity. Okay. Fluid should be take very low velocity. Then we can identify some laminar flows. Okay. I will draw profile, velocity profile for laminar flow. It should be parabolic. Okay. In this area, velocity should be maximum. Okay. Then this area velocity should be minimum. This area also same. Okay. Then RE mean Reynolds number. Reynolds number. Okay. This Reynolds number you can get using this equation. It's mean inertial forces divided by viscous forces. Okay. Inertial force you can calculate rho dV. Rho mean fluid density. D mean pipe diameter. Okay. Then V mean fluid velocity. Okay. Then mu mean viscous force. You can identify fluid dynamic viscosity. Okay. Mu mean viscous forces. So in laminar flow, RE Reynolds number should be lower than 2300. Okay. Should be lower than 2300. Okay. According to Reynolds number, we can identify is this laminar, is this turbulent, is this flow transient flow. We can identify using this Reynolds number. Okay. I will give some example after completing this lecture to find using this Reynolds number. So next thing I will discuss transient flow. What is the transient flow? Transient flow means this type of flow consists with laminar flow and turbulent flow both. Okay. This means flowing streamline and turbulent both. It's mean when we are taking pipe and I consider fluid is going through this pipe and I will draw one line. I will take one particle and draw one line. Firstly, it will be go smoothly. It's mean a straight way. Then after that, I will draw some barrier. Okay, here. Then after this barrier, this particle will be moved different directions. Okay, it's mean it will be turbulent flow. Then after that again it will come to straight line. Come to a straight line. Okay. This type of fluid we can call transient flow. Okay. Fluid at relatively high speed but less than complete turbulent velocity. Okay. You can identify this type of fluid using this Reynolds number. Okay. It's mean RE should be greater than 200, 2300 and should be less than 4000. Okay, should be greater than 2300 and should be lower than 4000. Okay, then finally turbulent mean I can get a pipeline and I consider fluid is going through this pipeline, then its particle behave like different directions. Okay, like this. Okay, it's more different way. Okay, so this type of fluid we can identify using this Reynolds number. Reynolds number should be greater than 4000. Okay, Reynolds number should be greater than 4000. You can identify using this command. Okay, so these are the things in a laminar versus turbulent. Okay, you should remember these things. It's very important. Laminar, turbulent, and also Reynolds number. Reynolds number. It is very important thing. Okay, you can identify flow types using this Reynolds number. Okay, which flow? Laminar flow, transient flow, turbulent flow. You can identify using Reynolds number RE equation. RE rho dV divided by V. Okay, you should remember these things. Okay, you can see using this figure, this is the laminar flow. Okay, this is go very straight way, and this is the transient flow. Starting is straight, but after that it's move different direction. Then again it will be straight. Okay, then finally turbulent means it's move on different directions. Okay, these are the diagrams you can identify, streamline diagrams. Okay, laminar flow. This is a laminar flow, uniform one. Okay, uniform one. This one is non-uniform. Can you see this area? Okay, this area velocity is greater than figure A velocities. Okay, this area velocity is greater than. Right. Then non-uniform means this one. Then turbulent flow. This type of fluid motion is very different way. Fluid particle is moving different way. Okay. I will given this one, Reynolds number, transient Reynolds number, turbulent Reynolds number. Okay, you can use these things. Okay. Laminar flow. Fluid particle move in layers. We have discussed. So do not disturb the fluid particle in adjacent layer. Okay, it's mean no any cross between streamlines. Okay, streamlines. There are no any cross with the streamlines. No mixing between layers. Okay, layers. There are no any mixing between layers. Occurs at low volume of the Reynolds numbers. Viscous damping forces are larger than inertial forces. Viscous damping force mean this one. This one large. This one is very small value. Inertial forces is very small value in a laminar flow. Okay. Then laminar flow is predictable using mathematical techniques. Okay. We will check in a future this part. Inertial force means force which help fluid to move. Okay. Then viscous force. Frictionless shear forces which develops between layers of the fluid due to its viscosity. Okay. Frictional shear forces which develop between the layers of the fluids due to its viscosity. This viscous forces occurs due to this viscosity, okay, between layers. So you should remember this equation, okay, Reynolds number equation. We have some calculations to do. Okay, so these are the application in laminar flow. Okay. We can consider laminar flow in a pipe. Okay. We can consider fluid is going through a pipe, then can be generate laminar flow inside of the pipe. Its velocity should be low. Okay. Then in bearing, we can identify laminar flow. Okay. Inside of the bearing, we can identify laminar flow. We use some lubricant to move this bearing now. Then we can identify laminar flow inside of the lubricant. Okay. Lubricant flow in bearings. Okay. Then in hydraulic dampers also, inside of the hydraulic damper, this hydraulic damper working using hydraulic coil. Okay. Then in this type of damper cylinders, we can identify laminar flow. Okay, in this area, you can identify laminar flows. Okay, some fluid coming to the cylinder, and after that, some fluids coming outside from the cylinder. Okay. Then turbulent flow means most of the flows in nature are turbulent. Okay. Most of the flows in nature are turbulent. Velocity is high. Okay. Laminar flow, in laminar flow velocity is low. Then turbulent flow velocity is high. So the Reynolds number also high. It's mean what? Inertial forces should be greater than viscous forces. Okay. Okay. Inertial forces domain the flow. Flow motion is highly random. No layered motion can be seen. Okay. Particles at different places mix each other rapidly. energy dispersion is high. Very difficult to predict using mathematical techniques. Okay, this type of turbulent flow we unable to analyze using mathematical techniques. Okay, it's very difficult to analyze. Okay, turbulent and transient flow also very difficult to analyze. Okay, so I will give one example for you. Please try to do this one using Reynolds number and what is the fluid type you can check using Reynolds number. Try to do this one and put it on your Dropbox, sorry, chat box. Share your answer using chat box. What is the value for Reynolds number and which type of fluid? This one. Density is 1000, fluid density. And also pipe diameter is 0.1 millimeter. And velocity is 2 meters per second. Viscosity is 0.001. It's mean mu. You can directly apply it to the equation and after that you can get the answer. Answer is how much? You should remember these things in this lecture series, fluid statistics, fluid dynamics, what is the basic things and can remember idea of aerodynamics, hydrodynamics, what are the applications, and you need to remember fluid flow types, uniform flow, non-uniform flow, steady flow, unsteady flow, and also incompressible, compressible flow. Incompressible mean constant density and volume. Compressible mean variable density and volume. And also non-viscous flow, viscous flow, how to draw a velocity profile. You need to remember laminar velocity profile and turbulent. How can we draw these things? What are the layers in this fluid? How is the behavior in fluid layers? And what are the differences between real fluid and ideal fluids? You can compare, you should compare. And what are the profile, velocity profile in a real fluid versus ideal fluid? You should remember. And also, this is very important thing, laminar versus turbulent flow. Okay, and also Reynolds now. You should remember. These things you should remember because you have to do some calculations and you need to identify what are the type of flow, these things. You can search some what are the applications in the laminar flow and also turbulent. Please drop your answer. Reynolds number 0.2. 2 lakhs. 20,000. You can apply directly. 1,000 multiplied by V mean velocity 2 multiplied by D mean diameter 0.1. Okay. Then divided by mu. What is the answer? coolants, ne? It's mean this fluid is become turbulent. No? Reynolds number is uh, greater than 4,000, no? Then we can consider this fluid is turbulent flow. Okay, I will show some video for you. Okay, this video consists with the application of turbulent and laminar flow. Can you see it? Can you see this video? Can you see this video?
No, sir.
No. Now is it no? Is it okay?
No, sir.
Can you see now? Another.
No, sir.
Another. Sampai another.
Yes, sir. Pena.
Penane? Okay. Okay, I think you have got the idea about the laminar and turbulent flow using this video. Okay. Okay. Today lesson I will wind up now. So next day we will discuss what is the discharge in a fluid and also what are the open system, closed system, discharge in flow rates. We will discuss how to calculate flow rate, what are the equations for, and these things we will discuss in next day. Okay, I will give some questions for you. You can calculate. And these things we will discuss. Today is first day. So I will wind up now. If you have any questions, you can put on your chat box. You can use this reference book for your education purpose. Okay. Hydraulic and fluid mechanics, including hydraulic machines by P.N. Modi. And also you can use this fifth edition, John F. Douglas and Jonas M. Gasioric, John A. Their books. These books you can use as a reference book for your education purpose. Okay. This Modi book is very famous one. Now I will wind up session. Yes, I will upload this lecture notes for your Moodle. It's mean VLE. I will upload. Okay, I will share this lecture note with you using your VLE. I think, oh, okay. I will wind up this session. Thank you all. You are joining. Thank you very much for your joining. So, okay.